Hello everyone, so in this video, let us talk about the latest AtCoder Beginner Contest 300. First three problems in this video. I'll make a separate video for the D problem as well as an E problem, so stay tuned on this channel as well. So the first problem goes like this, that there are n choice question. So you are given two integers a and b. You have to find out a plus b, and there is a n choice problem. Find the ith choice, which is ci, and print out the index of the correct choice. It simply and like makes sense that you are given two integers a and b. You have to find out the answer, and then the answer is actually, like, you can say, a n choice problem. So you are given n choice and you just have to select the which one you have to like tick it. So you just have to print out the index of it. So giving some example, you can understand that you are given this as an input. If you add both of these numbers, that is a and b, the total becomes equal to 300. Now 300 will be among all of these n choices that is given to you as an input again. Now the input or the actual 300 is here, so you will just print out this is the second index. Pretty much simple. That's the whole idea. So you can just add both of this a and b and iterate over this whole array from left to right, and wherever you find out a plus b as the output, like the actual option, you just print out the index starting from one index. Okay, and that's the complete logic for the first problem. Nothing much complicated here itself. Let's go to the next problem. The next problem is not too difficult, but yeah, thoda, it means that it has a little bit uh, code intensive. Like you have to like little bit think of how you can write the code for it. The problem name is same map in the RPG world. So the problem statement goes like this, that you're given or actually Takashi is developing an RPG, let's say game or like a world, and two maps are called equal if they fulfill the particular condition. The condition is that we have a grid A and B. Both of them has H horizontal rows and W vertical columns that is given to you. Now each cell in the grid will be either hash or a dot written on it, as you can see in the input. Okay, so it has, let's say, 4 rows and 3 columns. Okay, now what you'll actually have to do is that the symbol written on the cells get denoted by AIBJ. That is simple. Okay, so this is like the symbol that is dot or hash. Now the following two operations can be called a vertical shift or a horizontal shift. Now these are vertical shift or horizontal shift. The vertical shift just means that you will take all the rows one by one of that particular matrix and shift it one position on the top, like one position, not like you can say shift every row one position on the top. Okay, so in simple terms, if you just I'll show you with some example as well. And horizontal shift means that you're shifting on the left hand side, like every column shifted to the one shift on the left hand side. So these are vertical shift and horizontal shift on a particular map. Now, is there a pair of non-negative S and T that satisfy the following condition? Yes or no? You have to just find out that whether this condition is satisfied. That after applying a vertical shift S time, you have to first apply vertical shift S time and then a horizontal shift T times, can A becomes equal to B. So you're given two maps, okay, with hash and dots. So you can do is there a possible S and T such that you will first do vertical S time shifts and then a horizontal T time shifts on a map A so that it will become equal to B? Is it possible or not? Now the constraints are pretty small. So what you can directly easily do here is that you have to find out that whether there are some shifts on the map such that like they both become equal. Now if you like try to do it in a very like try to match it everything, like there are multiple approaches as in here, but the very simple can be, because the constraints are pretty much very small. What you can do is that you can find out every possible shifts for S and T, because if H and W is of maximum 30 size, which means that if there is a matrix of, let's say, 30 rows and columns, what will happen is, because it is like a circular shift, you will keep on shifting it on the top. I'll show you what the shift is, but it will circle, it is a circle, and it will come down to the same, let's say, shift. So you will have to do at most 30 shifts on the very vertical shifts, at most 30 shifts on the like horizontal shifts and vertical shifts. That's the very maximum number of matrices you can get up to, that is 900 operations you will do. And in operation you can just find out that, okay, if I have to do one vertical shift and two horizontal shift, or let's say three vertical shift, five horizontal shifts, and so on, you will just keep on finding out that, and then you will do this number of horizontal shift and vertical shift and just check that whether the two matrix or two maps becomes equal or not. Okay, now what is a vertical shift or horizontal shift? Let's talk about that very quickly. So what you can see is that for a vertical shift, let's say these are the rows, you will shift all these rows on top of each other, like one shift on the very top. So you can just see that vertical shift means that this row come here, this row come here, this row come here, and this row goes to the very bottom, and this row comes here. So it's like a circular shift, doing once like shifting all rows on top of each other one step. Okay, and similarly for that, horizontal shift is like shifting one step on the left hand side. So this column come here, this column come here, this column come here, and this column will go here. Okay, that's what vertical shift and horizontal shift is. Okay, now what you can directly understand here is that how can we do vertical shifting just very fast. So what you can do is that if I need to do it one by one, it's very simple that like if you just assume this matrix or it is like a 1D array, it is also very simple that what you can do is that if you want to do vertical shift, let's say 3 times, so it just directly means that just take the let's say the last row shifted 3 times, like every row shifted 3 times. So if it go out of bound, you will like mod it with the number of let's say rows it has, and then it goes to the correct position. So you will just take every row and like shift it that number of times. So you always have that I have to shift it 3 times or like 1 time and so on. So you will just take it this number and just shift the rows, and you have to first shift a vertical shift and then the horizontal shift, and whatever is the final matrix, you will just match that with a is equal to b, and then you can just print the answer. Okay, if you just find out one of the possible case that matches out. So nothing much complicated here itself. Let's find out what's my logic here. So it's now the code is a little bit intensive, but the actual logic is not. Okay, so what we'll do is I'll show you from the very beginning. So we have this solve function that will take the input of h and w, the you can say the size of the matrix A and B, then print out the A and B matrix. This is the copy matrix because I have to do this operation from the very beginning A. So I have a matrix, and then I'll do a vertical shift and horizontal shift. So I will have to keep on sending the starting, let's say the starting value of A, and then we'll do have to do this operation. So we have a copy of A as well. Now we'll take the input of A and B, and what we'll do is that we will find out for every possible shifts. So the maximum possible shift can be let's say up to h in a vertical shift, like all the rows shifted one time, like at maximum n minus one time, because if zero it will become the same matrix. So from 0 till h, and for horizontal it is from 0 till w. And then what we'll do is that we'll first do a vertical shift with I number of vertical shifts, and then this return the new array, okay, the copy of A, and then this copy of A is sent to do a horizontal shift. So this horizontal vertical shift just take the, let's say, matrix and return a new matrix that is vertically shift I number of times, and this returns a matrix that is what horizontally shift j number of times. And then you just have to check that A and B becomes equal, else yes or no. Okay, now this is simply these two functions. This check function will just check that whether the two matrices are equal or not. Okay, now vertical shift will take, as you can see, this matrix. I will make a new matrix here itself, new way, and then take the, you can say, the original ith value, the complete row, and add the shift, mod it with h so that it will like do a circular add, and then return the new let's say the new matrix for the row wise, or that is the vertical shift. This is the horizontal shift because like shifting every column on the right hand side, also the left hand side, mod w. That's simple. That's the overall logic. So like even if you do right shift, left shift, doesn't matter because you just have to just find out that whether it will become equal or not. Even if you do a left shift or right shift, it is a circular matrix, so like circular operation, so it will comes down to the same operation if you do right shift or left shift. Okay, that's the overall idea and the logic. You can just pause out the let's say video for here for the code part. I will also put the code link in the description of this particular video. Okay, the last problem is as you can see, cross, in which it is also like logic, not logic. Logic is simple, it's just like implementation heavy. So as you can see that you're given some matrix h comma w, as you can see here, it also has some hashes and dots. Now you can just read what they're actually trying about, but I'll just show you that what they're trying to say is that you have to find out these crosses. Okay, like what is the cross, you can say like every cross is not independent of other crosses. As you can see that there is some physical difference between them. As you can see that there are some dots or everything. So these are dots which doesn't matter to us. This like empty spaces. We just have to focus on these hashes which are forming crosses. And then what you actually are trying to do is that just find out like how many crosses are there. Okay, how many crosses are there? So what is the cross size? There is some cross size. So this is a cross size of size 1. This is a cross of size 2. Why? Because you can see that it has one extending hand or like extending out. So this is a cross of size 1. This is a cross of size 2. Okay, and so on. So these are different crosses. So you just have to find out like how many crosses are there of every type. That's it. So as you can see that this is the input. So as you can see that this is how many crosses are of size 1, crosses of size 2, crosses of size 3, 4 and 5. So whatever is the, you can say, number of rows, you just have to print out for how many crosses are there of every type, and this array should be of the number of rows of the, you can say, of the matrix size. Okay, so if it is like 5, so you have to print out for every possible crosses of size 1, 2, 3, 4, 5. Okay, so there's one cross of size 1, one cross of size 2. So that's it. Moving forward, if I'll just show you one thing more, so this is of 3 size, so 3 outputs should be there, and there are 3 crosses of size 1, so that's it. And this is like a larger one. So it is also not much difficult. You just have to iterate over this complete matrix one by one, and then whenever you see a hash, let's say you land here or like here, whatever, you will do, let's say, a traversal on all the 4 directions. Like you will just check one by one that okay, is it a cross of size 1? If it is a cross of size 1, you will just keep on doing a while loop until it goes out of bound. If any one of these like say extensions go out of bound, you will stop. And what you will do is that you will keep on checking that if all of them are hash. If all of them are hash, you will extend your hand. Okay, let's say if all of, so you will first check that if it is a hash, all the 4 should be hashes. Then one more, all of them should be hashes. So you will keep on extending like this. So you will first do a for loop over this complete matrix, and whenever you find out a hash, you will keep on doing this extension, like extending out from all the directions. If you keep on finding out hashes, you will keep on adding it out, and when you will stop, if it is like a properly matrix, you will keep on adding it in some array of what is the cross size and just print the answer. Okay, that nothing much complicated here itself as well. So let's move on to the solution part. So what we have done here is that we have the matrix M n cross M. We'll take the input of all of them. Then this is the matrix to store out all the final answer. Okay, and then what we'll do is that we'll iterate over this complete matrix from the one from left to right, like row wise traversal. Whenever I find out a hash, what I'll do is that I will now check out that from this hash can a possible cross is possibly there. This check function will return the maximum size of the cross I can get centered at this hash. This will be returned by this check function, and I will just add that particular count in the map, like this B map, or you can say like a matrix. Not sorry, matrix. This is an array that will store the frequency of all the cross sizes that we have in the end, so that I can print out the end. Okay, so this is the minimum of n cross m. Whatever is the minimum size of n cross m, I will just print out that number of times. What is the maximum size of crosses we have possible from 1 till that number of size, and just print it out. So now what is this check function? This check function is also pretty much simple. It will start from that hash, and it will do a while loop until like we have gone out of bound. The out of bound case is that if we have gone out of bound means that if we have not found a hash, or if we have so if we are inbound, as you can see, if we are inbound and it is a hash, then it is continue. If we gone out of bound and if it is not a hash, we can go out of bound, so it will become false. And what we'll do is that from a particular hash, we have to go in all the 4 directions. So all these 4 directions are mentioned here. So you can take that, okay, if it is of size 1, so what you can say is that if it is size 1, it multiply by 1. So I will just get the new let's say extensions of all the 4 directions and check that it is inbound and it is a hash, then it is okay, or else it is breaking. So I will get the k, what is the maximum k I can get, but because it's starting from the center element as well, so I will subtract one from it. Okay, so this is the size of the, you can say, cross, and for every size of cross I will just increment what is the size of the cross I will get centered at this hash, and just increment the total and just print out the matrix, or sorry, the array that we have for all the cross sizes. That's it. That's the logic for the third problem as well. And I hope you understand all the solutions. If you still have any doubts, you can mention it in the comment box of this particular video. I will see you in the next one. Coding, and bye.